Hi everyone, today I'm going to talk about forward training and backward training algorithms, which are two of the most important automated reasoning algorithms. First, the forward training algorithm. I'll talk about the idea and the knowledge base the algorithm will handle, and the algorithm itself. Then, I'll talk about the property of the algorithm and the source of efficiency for the running of the algorithm. Finally, I'll talk about some efficient versions of forward training algorithms. The idea of the algorithm is to start with some atomic sentence in the knowledge base and repeatedly apply general modus ponens rule in forward direction and add new facts to the knowledge base until the knowledge base does not change or the query is reached. The knowledge base to handle contains only definite clauses, and such knowledge base contains atomic sentence, and the implications in this form. The premise are a conjunction of positive literals, and the conclusion is a single positive literal. All the quantified sentences are converted using the inference rule, or the existential unified quantified sentence has been converted using the existential instantiation rule. But for the universal quantified sentence, we simply drop the unifier of the quantifier of the sentence. And the algorithm contains three parts actually, but I would like to say two. First is the premise match. The algorithm visits each rule in the knowledge base and try to find the conjunction of some facts in the knowledge base that unifies with the premise. If such substitution is found, we apply the substitution to the conclusion of the implication and add the resulting new fact to the knowledge base if it is not at the knowledge base already. These two steps repeat until the knowledge base does not change, which means the query cannot be entailed or the query has been reached. This is the algorithm. The algorithm visits all the rules in the knowledge base, and for each rule try to match the premise of the implication with the conjunction with some facts in the knowledge base. If a substitution was found, apply this substitution to the conclusion and generate a new sentence. Add this sentence to the knowledge base if it is not already in the knowledge base. And if the goal query has been reached, we just return the unifier. Otherwise, we repeat this process until the knowledge base does not change. Here is an example. The algorithm will scan the implications one by one. First, it scanned the first implications and found that some of the conjuncts of the premise cannot be satisfied. So it scanned the next one, and it found that the premise unifies with these two facts here, and the new fact, south, west, and no is added to the knowledge base. And the program continues to scan this sentence, and by missile M, it can infer that weapon M. And then the program scans and this fact is added to the knowledge base. The program then scans the implication number 4, and by this fact, the new fact, hostile, no, is added to the knowledge base. And by all these facts, the conjuncts in the premise of the implication number 1 can be satisfied, and the conclusion can be added to the knowledge base, which is the query we want to prove. And the property of the algorithm. The forward training algorithm is both sound and complete. It is sound because it is simply application of general modus ponens rule, and it is complete because it terminates. Let K be the maximum number of arity, a maximum arity of predicate, P be the number of predicates, and N be the number of constant symbols. The maximum number of facts generated by the algorithm is this. And so there are at most this many iterations. After this many iterations, the algorithm will complete. But for general definite clauses with function symbols, the algorithm can generate infinite new facts. That is the problem for this algorithm. And the source of inefficiency for the algorithm, first, it tries to find all possible unifiers such that the premise of a rule matches with a conjunction of some facts in the knowledge base. And the second, in every rule, it tries to recheck every rule in every iteration to see whether its premise is satisfied. And three, we can see very obviously irrelevant facts are also considered and generated during execution, which is very huge source of inefficiency. For source one, we can we can find an optimal ordering of facts when we try to match the rule with the premise. For example, for this implication, instead of find all the objects owned by no-no and then check whether they are missile, we should find all the missiles first and check whether they are owned by no-no. If there are many objects owned by no-no and very few objects that are missiles. The good news is that we do not need to consider the size of rules or the arities of predicates because they are bounded. All we have to consider is the number of ground facts in the knowledge base, which we call data complexity. And we only have to consider the subclasses of rules for which matching is efficient. And for source 2, we developed a technique called incremental forward training. It stems from the observation that every new fact inferred on iteration t must be derived from at least one new fact inferred on iteration t minus 1. So we check a rule only if its premise includes a conjunct that unifies with a fact newly inferred at the previous iteration. And we match this fact with this conjunct and let the other conjuncts to unify with all the other facts inferred in previous iterations. And in this way, the algorithm runs only when new facts are added to the knowledge base. The second approach is that when a fact comes, we, instead of immediately discard the fact, if the match is not complete for the premise, we retain and gradually complete the partial match. And for source 3, the most obvious approach is to use the backward training. And the second approach is to rewrite the set of rules using information from the goal. We add the magic term, and we add a new fact. And we add a new fact to the knowledge base, so that to constrain the values considered in the during the forward inference. For backward training, I'll talk about the algorithm, the idea of the algorithm. This algorithm is carried out in an AND/OR search manner. The OR procedure match conclusion of the implications, which means it finds the rule whose conclusion matches the target, and the AND procedure break premises. They try to separate the premises for the OR procedure to handle. And in each step, in each recursion, the AND procedure break the target into which is the premise of an implication into two parts, first and rest. For first, it used the or procedure to match a rule, and for the rest procedure, and for the rest, it recursively calls itself to separate until rest is empty. This is the core hierarchy of the two procedure. The or procedure matches the conclusion of rules, and the and procedure break the target into two parts, first and rest. For first, the first is passed to the or procedure to match a rule, and the rest is passed to the end itself to separate and separate again until the rest is empty. This is the detailed code hierarchy. You can see here, first and target is not the same. The rest and target is the same because it is the parameter of n procedure. But this and this is the conclusion, and this is the premise. We use this to find the premise and we call n to separate this target into first and rest. This is the code for the algorithm. For the or procedure, we match a rule by first standardize the variables and pass the premise to the end procedure to separate the premises. And for the end procedure, the procedure terminates when nothing can be extracted. And what the end procedure mainly do is to separate the goal, which is the premise of implications, into two parts, first and rest. For first, it uses the or procedure to find an implication, and for rest, associated with the first, it is handled in the inner loop with an end procedure to further separate. Notice that each first and rest is associated together, so they are organized into a nested loop. And the resulting unifier will be yielded using a generator. Okay, that's all for today. Thank you.
Yeah, cảm ơn.